All right. Why don't we get started? Sorry, we had to start about 10 minutes late. It was due to the keynote ran a little long, so they wanted us to start a little later. First of all, I'm excited to be here. We have a team of folks here to kind of give you an exciting presentation, some very cool demos that I think will illustrate a lot of work we're doing around data, and an exciting time. I'm Tracy Doherty, Group Program Manager from SQL. One of the things my team's directly responsible for is the IaaS work in SQL 14 that's coming out, so we've got some exciting things to show you in that regard. First thing about this whole thing is we want to talk about how do we connect these set of technologies that we're building to actually solving the problems that you guys will be experiencing or are experiencing as they relate to getting more clarity around data and finding the results of that. And so you'll find that through our demos, we'll talk about data warehousing, PDW, we'll talk about big data, which is our HD Insights service, or Hadoop, if you want to think about it that way, Excel, of the enhancements of how it makes it easier to look at the data, and then lastly, SQL 14, and we'll talk about some exciting things that we're tackling in that regard. Just as a show of hands, first off, how many people are familiar with PDW in the room? Okay, so it's a small set of folks, so we'll talk to that a little bit. How many folks are familiar with Hadoop? How many feel like they need to understand Hadoop a lot better? Okay, so it's a common theme that we are finding. We'll go through that. We'll show some of the tools that we have to make life a little bit easier in that regard. And the demos will help illustrate that as we go through it. So I always like to start these sessions with kind of a story. And this is a story about data. The story I'm going to tell you about is about data. You could say it's a medical story. You could say it's a city story. But I like to focus it on the data side. And it goes back to 1854 in London with this aspiring physician, John Snow. And so there was this outbreak I think the proper pronunciation is cholera, which is this bacterial infection in your small intestine. And so they had this outbreak of this where people were dying from it, getting really sick from it. And he wanted to figure out why this was, and then, how they would fix it or cure it. And so he took this interesting approach that he did this analysis to find out where the outbreak was in the region. Where were they seeing these outbreaks from individuals and going through it? And so he determined this, and he came out with this map in this regard. Now, the interesting thing about it, you got to think about it, in 1854, they believed all these sort of illnesses were transferred via air. They didn't believe they could be transferred via touch or water or anything else. But in his evaluation, we looked at the map, he realized that there was this Broad Street pump, this water pump, right in the middle of where he was seeing this outbreak. And so he became pretty convinced that it was a water issue that was transferring the disease to folks. Now again, you got to go back and remember, society at that point didn't believe that's how diseases were transmitted. So we got a fair amount of pushback. So he went to the city council and said, hey, I think it's this pump, we should turn this pump off, it's making a lot of people sick. Well, the city council came back and they looked at some of the data and they said, well, where you have all these blue dots, these are folks that are sick or became sick, but they're not in your area, and they actually where their homes aren't served by this pump station, and they don't use that. So that's kind of bizarre. And then secondly, they said, there's also this big beer brewery right next door to this place, and none of those people are sick, and there's a lot of people that work there and live there, and they're not sick as well. So they really challenged him on this. So what he did, he enlisted the services of Henry Whitehead, who was kind of an expert in the area, to help him get another set of data, basically a second set of data to go back and do a deeper dive on this. And then John Snow did as well, and they went into the community and kind of did some research on these certain things. Well, there was kind of two fascinating things they found out. One, the dots that you see on the outside of the circle happened to be families that their children went to schools inside the area. So they actually were consuming the water, and they came home and were sick from that. So that dispelled one of the anomalies that they had. The second one, and I think is interesting and almost humorous as well, is the brewery was right there. Well, why was nobody sick from that? Well, it turns out the brewery has its own water source that they used, and so those that chose to drink water from there used that. They weren't sick. Secondly, the brewery had an interesting policy that allowed each of its employees to have a certain amount of beer each day. And we don't know how much that was, but I'm guessing it's a significant amount. And so they didn't get sick either. And maybe you could take the short story of this is, hey, if you drink a lot of beer, you're not going to get this disease. But they broke this down and separated out in that regard. They then went back to the city council with this additional data and then convinced them of how the data was reflected on, what they should do, and they ultimately shut down the pump on this pump station so that people would stop getting sick. Now, the fascinating part about that, if you take it from a data analyst perspective, you'd go through and say, well, his first view of the data drew on this map was this initial set of data that described the what. It described what the problem was, kind of gave an intuition of what he thought it was, and tackled it. But then he had to go get external data sources to really refine that data and prove it to the point of determining what was causing it. What was the why factor that came along with that. And then the third phase was the action that they took place to actually fix the problem. And in this case was shutting off the pump. Now, in this case, and I think this is important, the immediate action was to shut off the pump, and so people wouldn't get sick. The long-term action of this was it changed actually the way society looked at diseases being transferred via water. It also changed the way cities dealt with the sanitization of water supplies in their environment. So it had a very, very huge impact that's driven from this particular impact in time. Now, the other reason I show this slide, because it has 3 phases. In the presentation today, I'll break our demos down also by these 3 different phases, which will go into the phase. The first phase will be about how do we collect data and what are the data sources. The second part will be how do we analyze it? How do we make it easier for somebody to look at the data, determine what the real problems are? And then the third part will show how you can actually operationalize it or do changes in that regard. So this slide you'll see a couple times, but just remember as we relate to that. The other thing is you highlight through these different phases, they typically involve different people in our industry. Somebody in the beginning is more of a data expert. Somebody in the middle is more of somebody who would be using Excel and operate it on the data and having a quick influence on it. And the third one can vary depending upon what the action is. And so we'll try to highlight those different personas as we go through. Okay. So I think if you were at the keynote, you probably heard a little bit of this point as well, as where big data is driving a massive tipping point for us. I think Aaron mentioned there's been more data created in the last 2 years than in the history of all of mankind. Another thing that I'd heard was if you take a baby that's born today, in its first week, there's more data created around that newborn than there is around a typical 40-year-old's lifetime span. So they kind of map up. And you think about it of just the social media, the photos, everything involved with that is very dramatic. But if you break it down to a high level, you kind of go, why is that? And there's massive amounts of data. There's coming from multiple sources. There's many data types from those sources. You can't expect from mobile devices to appliances to cars to et cetera. They all have varying data types that they come from. And then a lot of these are creating this data in real time. So it's not human generated, it's device generated. So all 4 of those top things together is what allows this massive growth. But if you look at the bottom 2 that I have on here, this is where I believe the change takes place, where hardware and storage economics are such that you can have massive amounts of data and you don't throw it away. I'll give you a view. Even in my job, up to as recently 2 years ago when we build these software products and we have a lot of telemetry in the back end that report what customers are using and how they're using it, we would always take the viewpoint of what exactly do we need, what's the minimal set we need, and then get rid of everything else, because we couldn't afford, 1, the storage of it, and 2, we couldn't afford to figure out how to process it all in that regard. Well, that's changing in this world now, because the storage of it is actually very, very cheap by and large. Secondly, it's very hard to know exactly what you need from your data ahead of time. And so there tends to be more questions than answers. And so we try not to limit ourselves in that. And that goes to the bottom right-hand corner. Whereas user expectations are different. Just in the last 2 years, if I just look at me personally, my expectations of my team is I want to know what that data means right away. And I don't want to hear back, well, we didn't get that data, or that's going to take us months to figure it out. I want us to understand it quickly so we can turn it into action. And so I think these 6 points, if you will, is a dramatic change both in the quantity and our behaviors of how we want to deal with that quantity as we go forward. So a lot of what we'll show you is to help manage this data and try to process it and come up with the insights to it and feed into real action in that regard. Okay. So again, we use the 3 points that we go through here, and we'll base this off of all our demos based off this fictitious airlines that we've created called Blue Yonder Airlines. Now, Blue Yonder Airlines, we're going to, for the sake of it, it's a U.S. Airlines, so you'll see the data that we show later on is U.S. based. Also, if we wanted to, if you look at the very top, if we really wanted to use data to increase customer satisfaction in the airline industry, you would probably pick a U.S. Airlines to do that, right? Most of your European airlines don't have as many of the problems that the U.S. airlines do of going through that. And so that's why we tackle that. The second part is we'll break these things down into the data that you would typically want. And so our goal of this is to increase customer satisfaction. We'll be particularly looking at our mileage program for our most advanced customers as we go through this, and we'll look at the various data sources that we have available to us to help us drive that through. So the first one will be on finding and combining and managing the set of data that we have as we go through it. And the thing, if you go back to when I said the data is a tipping point of multiple types, most of us in here are very familiar with the relational data. But there's a huge amounts of non-relational data that exists from various data types. But yet you want to be able to query and gain that information and knowledge across both types. And so Polybase helps us do that, and we'll talk to that a little bit. And then the other part was Hadoop data, just massive amounts of data that exists there. And so we have Windows Azure HD Insight to help in that regard. And so rather than me talk to these in great detail, what I'm going to do is bring up Andy, and he's going to walk through a demo of these pieces of these first phase that we can do. And so I want to picture Andy as more of your IT expert in your organization. He knows where to find the data. He knows how to pull it together, and he's going to walk us through that process.
Okay, thanks, Tracy. As Tracy said, my name is Andy Conrad. I'm a developer on the HD Insight team at Microsoft, so I work on big data. For the sake of this demo, we're just going to pretend that I'm an IT a worker for Blue Yonder Airlines. And for the first part of the demo, I'm trying to find and kind of combine and manage a bunch of data from a bunch of different data sources. To start off with, our airline's like any typical airline. We have a data warehouse, and we stuff a bunch of data in here, anything from flight information to reservation information to information we got from our customers. And to demonstrate that, I'm going to open up a management studio and query my PDW database. So here I have Blue Yonder Airlines, and I'm going to select from a table called Flights. Whoops. Type it correctly. Okay, so this is kind of a simplified example, but this is flight data that we've put together in our database. What this has is it has a date, it has an origin city, this is where the flights took off from, and it has the average delay for these flights. So you can imagine I have a whole bunch of data like this, and I've already aggregated into a table, but it's still a lot of data. Now what I want to do is I want to go out and try to find some data sources that are basically showing what my customers think of my airlines. And a really easy way these days is to harvest this from a number of the different social websites. Now for this demo, what I did is I went out to Twitter and I looked for all the references in the same time period to my airline. And I'll show you what Twitter gave me. So this is a JSON file that Twitter, when I asked the service, do you have tweets referencing Blue Yonder Airlines, this is the feed I got back from them. Now, I really, really want to combine this and join this with the flight data I just showed. But unfortunately, it's in JSON. It's semi-structured. It's jagged. It's not really ready to run queries over the top of. Now, to get this in a form that I could actually join it with the flight data, I'm going to use one of the applications that's part of the Hadoop ecosystem called Pig. Has anybody in here heard of Pig? A few people. Okay, so we're going to talk a bit more about Hadoop later, but Pig is simply a data warehousing application that's part of Hadoop. And what this does is it provides a language called Pig Latin that's really good at kind of processing files and doing ETL on the files and getting it in a format so you can run queries against it. The language for Pig is Pig Latin. This is Pig Latin right here. I'm not going to go into what it does, but I will tell you that this is going to generate two artifacts. The first artifact is what I call my sentiment data for my tweets. What this is I'm getting the date out of the tweet. If I can, I'm getting what airport they were tweeting from, and then I'm coming up with what's called a sentiment score. What I did is when I process it with the Pig script, there is a dictionary of words that I'm looking for that may likely indicate that my customer is unhappy. Stuff like hash fail, hash delay, hash bad airline, and I have a whole bunch of them. And what I'm doing is every time I find a tweet with one of these words, I'm upping the score. The score is kind of arbitrary, but what is important is kind of how it is relative from one airport to another. So what I want to do, well, so normally what I would do now, this data is sitting up in my Hadoop cluster in the Hadoop file system called HDFS. Normally I would take this data out and then BCP it into my data warehouse, and then I could do the join there. With this new technology that's part of PDW called Polybase, I don't need to do that anymore. And I'll show you why I don't. Here's a standard create table statement, a lot like anything you would do in your data warehouse. But there's a couple of key differences. The first is the external keyword here. This tells PDW that I want to use Polybase to access data that is not in or on my data warehouse server. And then the other part is I give the location down here. So this location is a URI to a file that is sitting in the HDFS file system. So this could be sitting anywhere as long as I have network connectivity and can get at it. Now what happens when I create this table is it doesn't copy the data into my data warehouse. It leaves it where it is. And in the case of Hadoop, when you have large amounts of data, this is a good idea just to leave it where it is. And then it creates a schema over the top of that data. So literally I ran this script before this session. It created a schema over the file I showed you. And now I can start running some queries against it. So the first query, I want to go and find what are the top 5 days that people were complaining about, basically using that sentiment score. So we're going to go back to SQL Server Management Studio. I'm going to put this query here. Now, the interesting thing here is there's nothing interesting. I just have 2 SQL tables now, and I'm just doing a join, and all I have to know is SQL. I don't have to know anything about Hadoop. I just have to know the location of the data file, and that was it. So I'm going to run this join here. And what comes out is there's a couple of days, actually the same day, November 22nd, a couple of our airports, it seems like that we have scores way above the rest of our scores. This is for Seattle on November 22nd and Chicago on November 22nd. Now, if I kind of compare that to the delay, there's almost 2 hours of delay for each of those. This is the average delay of flights taking off from those airports. So it's obvious, at least at this point, that customers probably were not very happy that their flights were delayed. Now,
so Andy, we should highlight in the past, an airline could obviously always see what their delay schedule was, and they could assume customers weren't happy if they saw long delays. But what you're saying is now we've got sentiment data that actually gives us a whole other flavor of data to come in and dive into that problem.
Yes. Awesome. So when I talked about the Pig Latin script, we'll go back to that again. I created 2 artifacts. The first was the sentiment scores that I showed you. The other thing is for each day in the month of November, I actually picked out the most popular words. And I put that in a different file. And then what I did is just like my sentiment table, I created a table called words. And this points at another file, which is the word counts for November 22nd. So let's go actually look at that table there. Again, I'm doing the same thing like I did before. I'm accessing Hadoop data from within my data warehouse using just SQL. So I run that. So the first word is airport. Second word is delay. Obviously, that's not really a surprise to me. People were not happy. They're probably tweeting about airports and delays. Weather comes up there, so that might be something that we might want to look into.
Yeah. Whoa. So the interesting thing to me, I look at your list, and you're right. They all look like fairly standard. But app?
Yeah, app is quite surprising.
I wouldn't have expected that. So
it's probably something else we need to look into.
Okay.
Now, just like all airlines, we have apps. We have many apps. I'm going to show one of them here. So this is our Windows Phone app. We also obviously have it for all the different mobile platforms. We also have a website. So we have, and if you guys are like me, anytime you're late or you're stranded someplace or there's something going on with your flights, the first thing I do is I pull out my phone and I pull up the app and I want to see what's going on. So Blue Yonder Airlines, we have a standard kind of airline app. I can check in, I can look at my rewards, and I can also look at my flights. I can see that things are delayed. I can see statuses. I can try to change it. When we saw app come up in the word list there, it's clear that something was going on with our app on those days also. So to look more into this, I'm going to load our log data from our mobile apps. And now what this is just like iOS or Windows, our app keeps a log file every time our apps make a request to our service. This keeps track of when the request started, how long it was, what the platform was, and then more importantly, we also keep track of if this is our preferred customer or a general customer. Now I have probably gigabytes, maybe terabytes of this data. You can think about every time my app is hitting the service, I'm writing a line into this file. Now what I want to do is I want to get this data up into Hadoop and process it there. And if this is basically what Hadoop was built for. Is to process huge amounts of data and put it in a format which you can do further analysis on. So to do this, I'm going to go into Windows Azure and I'm going to create what we call an HD Insight cluster. Now, HD Insight is basically Hadoop running on Windows Azure, and that's our product right now for Hadoop. So to do this, I'm going to go into the Windows Azure portal, and I'm going to go to HD Insight, and I'm just going to say New, say Quick Create. I'm just going to give it a cluster name. I can specify the cluster size. I'm just going to say 4 data nodes. So this means this is a 5-machine cluster. Then I'm going to pick my Azure subscription. I'll pick a password. And Azure's a little picky about this, so. And then the most important part of this, I'm going to pick a storage account. Now, traditionally, Hadoop runs over the HDFS file system, which is a distributed file system that you would run over several different machines. In Azure, when we host Hadoop, the storage we use is Azure Blob Storage. And the reason for this is we want to really move to a model where the data is persisted and the cluster is transient. So what I would normally do with my logs is every night I would push my logs up to Azure Blob Storage, and as needed, I would create an Azure cluster over the top of this to do my querying and my processing, and then when I'm done with it, I would tear this down. So I'm going to go ahead and create that cluster. So that's creating. That actually is going to take about 15 minutes to provision. So what I did ahead of time is I created a different cluster in the same manner called TechEd Blue Yonder Airlines. So when you click on this...
So let me make sure I get that right, though. To create that whole cluster is 15 minutes worth of work. It's not...
No, I did all the work there.
Yeah.
And then it's going to take 15 minutes for Azure to provision.
But we're not talking several days or hours.
No, that's all you need to do is create a Hadoop cluster.
Awesome.
So we'll come back to our TechEd Blue Yonder Airlines. So this is the page that you land on when you click on your cluster. I actually want to connect to the cluster, and I'm going to select Manage Cluster. So this comes up with our dashboard. I can do stuff like look at the job history, monitor the cluster, look at samples. What I want to do is click on the interactive console here. And there's 2 ways to interact with HD Insight right now. One is with JavaScript, and one is with a Hadoop application called Hive. Now, Hive is a data warehousing application that comes with Hadoop. It uses a query language called the Hive query language. But the really nice thing here is if you know SQL, you know 99.9% of the Hive query language. It is very SQL-like and very similar, and there's just a few differences. So what I want to do is, so what I've done is every night, those log files I showed you, I pushed up to my Azure Blob Storage, and I want to create a table over the top of that so I can start running queries. So I'm going to go back, and here's my create table statement. Now, this probably looks really familiar to the one we showed earlier when I was using Polybase. This has, I create the table, and it has my schema right here. I'm saying external because I'm telling Hadoop that this is stored in text files. And then one of the things, when Tracy mentioned when we were talking about big data has a whole bunch of different formats. And Hadoop supports all these different formats. Mine is pretty simple. It's just comma delimited, and the lines are terminated by the new line. But you can do almost any format in the world as long as you tell Hadoop about it. So I'm telling Hadoop about my format. And finally, I'm also, just like Polybase, I'm giving my location here. Now, this is a little different URI than I showed before. The ASV tells Hadoop that it's stored in blob storage. What we've done is we've built a plugin to HDFS that makes blob storage look like HDFS. And then this gives the blob storage container, my account, and finally a directory called raw. The other key difference between this and the Polybase example I showed earlier is I don't need to give one single file. I actually just give a directory. So all the files in that directory are part of the table. This is pretty powerful because I can create the table and then update the table every night by just uploading a text file to my Azure Blob Storage. So let's go ahead and create that. This is probably going to take a second or two. Okay, so that created. Let's just select a few rows from that. So Hadoop, one thing to think about with Hadoop is it's designed to process a large amount of data. So quick queries like this are not necessarily as snappy as you would see in a normal SQL database. And the reason for that is because the data is distributed across a whole bunch of different data nodes, there's a bunch of infrastructure that needs to fire up to execute the query. In this case, it came back in almost 2 seconds. So there's our data there. So now I have my flight delay information in my data warehouse. I have my customer sentiment scores. I have information about my app logs. Now, the other word that came up was weather. So we want to get some weather data here. Now, to get that weather data, similar to the Twitter feed, what I did is I went out to a service in North America called NOAA, where you can get any sort of weather data you want. And it's free and it's publicly available. What I did, similar to the Twitter feed, is I downloaded that. That was in a JSON format. I had to run yet another pig script, and then I stored that in what I called the weather curated table in my Hadoop cluster, and then also created an external table for that. So now I've combined 4 different distinct data sources. They're all accessible. I can now query all of them, and it's time to move on to the analysis phase.
Yeah, great. Thank you, Andy. And stay here. You'll do the next part as we come back. If we go through what we're saying is the different phases. So that was phase 1. And remember what I was saying before. We wanted an expert to show us where the different data sources were and combine them. And Andy showed us 4 different sources, of which 2 or 3 of those would have been really hard to tackle a couple of years ago, even for the airlines industry. So it's a new set of data. But now, as you can see through it, though, there was a lot of tables, a lot of data. It's not in the format that you would actually expect your program manager or your marketing person of the airlines app to look at and figure out what they should do with it next. And that's the part we want to highlight going forward is how do we refine that now in more of a visual way that you can look at and then come to some more conclusions with. And so if you look at it, we've got all these apps out there pumping in data. We've got the different data sources. Andy's done a good job of collecting them in that part. But now we want to have a better reference to look at it in Excel and take advantage of that. If you were at the keynote, you saw some of the geo work that takes place there. Well, we're going to try to show you the same thing as it regards to the data that we just tackled in this regard. But it's always important for me to remind folks as we go through these, and you'll see it in each of these parts, we're really trying to enhance the tools we have so that you have this familiar experience as you go through it. is Andy showed in the first part. You've got this very similar language. You've got the queries. All those things are you're very used to. Same thing as you'll show in this next phase of Excel. So now I'd have Andy come back. Andy's now a different person in the org. He's coming in more of our person that thinks about our customer experience and the flight and the app, and he's been given a set of data now that he wants to go through and process and figure out what to do next.
Okay, thank you. So as Tracy said before, I was someone working for the IT department, and we gathered a bunch of data, and we have a theory that customers were not happy with our airline at a couple of airports in Seattle and Chicago on a given day. We think it might have been because of the weather. We think there might be something to do with the app. But what I'm going to do now is, you can imagine I'm an analyst for like the marketing team at Blue Yonder Airlines. And Andy, the IT pro, has told me all this data is available. Now I can start consuming it. It's in a size and a format that I can work with using tools like Excel. So let's bring Excel up. Now, I've already downloaded the flight information and the weather data. The flight information, I just used the standard. I connected to the SQL Server database and downloaded this into Excel. I'm sure most people have either done this or seen this. I also downloaded the weather information. Now, the other piece of the puzzle that we want to download is that mobile app log data. To do this, I'm going to use a tool that is in preview right now called Data Explorer. How many people are familiar with Data Explorer? Okay. Data Explorer is a way to discover data, and it's a way to handle a whole bunch of different data sources and bring it into Excel and work with it. So what I want to do is I want to import the data from HD Insight that I worked with before, the mobile app log data. To do this, I'm going to go from other data sources. I'm going to say from Windows Azure HD Insight. I'm going to give my cluster that we created before. So Data Explorer is going off, and it's connecting to my HD Insight cluster. Now, originally I talked about my app log files. There they are. These are just the raw ones. And then I created a curated one for the month of November, and that file's right here. So I'm going to go ahead and drill into that file. And when I say drill into that file, Data Explorer is actually getting a preview of the rows. Now, I know that the text is probably a little hard for people to read in the back. Unfortunately, at this point in preview, Data Explorer doesn't have a way to make it bigger. But what I want people to see is kind of the process I'm going through here, and then download Data Explorer and try it out and play with it. So Data Explorer went and got a preview of this file. It's not getting the whole thing. And what it did, it put all the data into a single column. So it doesn't really know anything about my format. But what I do know about my format. So the first thing I know is that it's delimited by columns. So I'm going to say split by column there. Now, once I do that, I see that the column headers are in the first row, so I'm going to use a feature called Use First Row as Headers. Then I see a couple of columns I don't really want, verb and URI. I don't really need that. And then the first column is now, it's both the date and the time. And if you remember, we just want to work kind of with the granularity of date. We don't need time. So I'm going to go ahead and change the type here. Now, remember we were talking about with Hadoop with a bunch of different data types. This isn't stored as a date time. It's stored as text right now. So I need to change that to a date time before I change it to just the date. So I'm telling Data Explorer I want to change that to the date time. And then I'll go transform that to just the date. So what's happening here is over a preview of the rows, Data Explorer is building up a number of steps that it needs to do to transform the data when it's exporting it into Excel. So I'm going to change the query here. I'm going to rename it. And then I'm going to go click Done here. So what's happening now is Data Explorer is going out to HD Insight. It's getting all the data, and it's applying that transformation that I built up before it imports it into Excel. Now, I did a fairly simple transformation. They can be much richer and much more complex than this. But the cool thing here is I'm able to access a random data source, text data just stored up in HD Insight, and pull it into Excel now. Now, what we want to do is we want to start playing with this data. We want to start looking at some visualizations of it and see maybe if we can see what was going on here. Now, the first thing we want to do is kind of look at the weather data. And to do that, I'm going to load another tool that's in preview right now for Excel called GeoFlow. So we're going to launch GeoFlow. And what I want to do is I want to kind of put the data that we have, put it on this map and see what it looks like and see if we can draw any conclusions. So the first thing we're going to do is look at weather. So to do this, I'm going to map latitude and longitude. Then I'm going to pick wind speed. One thing we need to shift over in North America, because as Tracy said, unfortunately, our airline with a lot of delays is only a North American airline. Now, what I want to do is I want to look at the wind speed, and to look at wind speed, I want to use a heat map. And then what I want to do is look at that wind speed by the date, and more specifically by the day. So now I have this little slider here, and I can actually look at how the weather was changing over the month based on that weather data I had. Let's zoom in just a little bit here. Now what I want to do is, now we have the kind of, based on the wind speed, we can kind of see what was going on with the weather. But what I want to do is layer now on top of that is what was going on with my delays. So I'm going to go to my, I'm going to go up and add a new layer. I'm going to go up to my flight data. This case, I'm going to map by city. I'm going to select delay. And again, we're going to go by date. And just like we did with the weather data, we want to go by the day and just look at the delays. So let's go back to the 22nd now. This is kind of the day in question. Let's change the perspective a little bit here. So we start to see that, well, we can go look at Chicago here. And that's actually not Chicago. So that actually wasn't the airport with the biggest delay that day. Chicago is one of these airports in here. And then we see Seattle over here. So what's interesting is originally we thought there was a big problem with Chicago, but clearly there was delays going on all over the Midwest. And if we look at the wind speed, there was probably a weather system in there that was causing a bunch of these delays. So this leads me to believe that this might not necessarily be a localized problem to Chicago and to Seattle. Now to further look into that, I'm going to layer on top of that our sentiment scores. Do the same thing I did before. And then go back to the 22nd. So the blue here is the sentiment score, and then the green is the delay. So you can see there were delays going on all over the place here. And in addition to that, there were people at kind of the smaller airports around Chicago that were also unhappy about their service. So this was not a problem specific to Chicago and Seattle. And once I kind of get this put on the map, I start to realize that. Now, what this leads me to believe is that maybe there was kind of a bigger problem going on with our app. That in addition to people not being happy with the weather and the delays, they were also having problems with their apps. And if you think about it, you know, with this kind of big regional problem going on, there are probably a lot of people using our apps and likely probably some contention problems. So to look into this, I'm going to take...
Well, and before you go there,
Yep.
Quick question. How many people 2 years ago used an app, on a flying app on their phone, an airline's app? How many people do today? A significant percentage difference. Okay. Just you guys don't get to see the view I get to see, but it's about 80 to 90% do now. 2 years ago you didn't. And so that's why it was interesting when we said app data. What is that? What does that come in? And so it'd be good to find out now because you can lay that on top.
Yes. So now to do that, I'm going to use another tool that comes with Excel called Power View. And this is a way to visualize over the top of my Power Pivot models. Now in this case, I've taken that app log data that we downloaded from Hadoop, and I've tried to see that what was the average delay for each request by dates in November. And if you look here, it's pretty consistent. We had a really good day on November 4th for some reason. But we go along here and we hit this day here. And it turns out that this is the 22nd. So as we talked about, people were being stranded, there were delays, they weren't happy, and then they were all using their apps at the same time. Now, interesting thing is if I go down here and I look at the different requests by user agent, so the different apps on the different platforms, the problem looks pretty consistent here, which leads me to believe that this was not a problem with any of our actual apps, but probably a problem with our back-end service, and something that we're really going to need to go look and dig into to find out if we could handle kind of that peak traffic on the 22nd. Now, the other thing that I'm looking at that I got from the mobile app log data is that a majority of the people using our apps were preferred customers. These are our frequent flyers, our business flyers, the people that we want to keep the happiest. So there's something here where I could have acted on this and basically, work with these people and acknowledge that we're having problems on the 22nd. They're probably frustrated with our apps, and promise in the future that we will do better.
Okay, thanks, Andy. As you can imagine, if you're responsible for this airline of increasing customer sat, and you looked at this data, you can't change weather delays. Weather happens, and you have those delays. But if you see this and you go, wow, there's not only are we have delays, but our preferred customers are the ones that are most upset. And now we've got a measurement other than somebody coming to the counter complaining. We've got a measurement that says what's really going on and what can we do to tackle that. And in Andy's last role, he could look at it and say, well, maybe our app should be more sophisticated and offer, pre-assign people to new rooms, pre-assign their new flight ahead of time, et cetera, along that line. But it also highlights this other big problem, which is it does tell us that we have something on the back end causing a problem. And this is where it comes into taking an action in that regard. What do you want to do to address the problem? And so it really is pretty obvious of going through. But the thing that wasn't super obvious, other than with the new data we added in, was there's a slowdown with people interacting with this app on this massive change that took place. And so we want to go through that and say, well, what are our tools that we can do to address that? How can we tackle that going forward? And the way we do that is SQL 14 has a new in-memory OLTP functionality, which in the keynote, you probably saw the BWin video, and they referred to it as Hackathon, which is our internal code name. In-memory OLTP is what we'll call it officially. And it really is the thing that allows us to increase the performance and throughput of what we're going through in this regard. And you can read the bullets on here, but effectively it says, where are your hot tables? Is there contention in the system, and how can we optimize that for memory? The thing I would highlight on this, and you'll hear us say it over and over again, it is built into SQL. You use SQL like you have before. It's not a separate product. You don't have to rewrite your app for it. You may have to tweak a few things to take advantage of it, but you don't have to do that. And it's designed to tackle the hotspots of your database. So it's not an all or nothing thing. You actually pick and choose the parts that you want to go through. So what I'm going to do now, I'm going to bring up Joost to walk us through the demo that shows that based upon the data that Andy's given us up to this point of what we do to tackle it in that regard.
Thank you, Tracy. So I'm the DBA at Blue Yonder Airlines, and I'm responsible for the flight ticket reservation system.
By the way, I should say Andy probably called him in a panic, saying, there's a big problem here. You need to figure this out, and we need to get it fixed.
So I'm very concerned. I'm very stressed because Andy calls me, and he calls my boss, and the app is running slow, the system is slow, and I did all I could to optimize the performance, but it is clearly not up to par when there are massive delays and the app is being hammered. So what you see on screen here is a simulator that I built. It's a simulator of the ticket reservation workload, which is designed to hammer the system, see what the performance is, and to troubleshoot any issues. Now, let me run the simulator. And it shows that I get a performance of about like 2,400 transactions per second in the system, which is pretty good. But it was clearly not meeting the business requirements when the app was really being hit hard by our customers. So let's take a look at what's going on under the hood to see if we can find out what the problem is here. So I'm going to look at these diagnostics. And you will see two bars on the screen here. The top bar, the green one, is the CPU utilization. The bottom one, the orange, is the latching in the system, the contention.
And what is latching?
What is latching? Well, disk-based database systems, they organize rows into pages to conveniently move them between disk and memory. And preserve consistency of these pages, you want to prevent multiple concurrent transactions from updating the same page. So one transaction comes in, takes a latch on the page, and other transactions that need to access rows on this page need to wait until this transaction is finished.
Okay,
And we
so you're saying this isn't a SQL Server problem. This is any disk-based database system problem.
That's right, Tracy.
Okay.
Any disk-based database system, any traditional database system uses latching, and you would see this problem. And we see here actually a lot of latching in the system. And because of the latching, you can also see I'm not able to utilize the CPU fully. So definitely some bottlenecks in here. So let me go ahead and stop the simulator. So as you heard from Tracy, the new SQL Server in-memory OLTP feature is used to optimize performance of these types of applications. So I want to see what this feature can do for the ticket reservation system. So the first thing I need to do is identify the hotspots in my application which would be candidates for migration to in-memory. Now, let me switch over to SQL Server Management Studio. So this comes with SQL Server 2014. And it allows me to analyze my workload and identify the hotspots. So I have here a management data warehouse set up. And I can look at one of the reports, namely the Transaction Performance Analysis report. This report will show me which parts of my application are running hot. It allows me to look at my tables, to find the hotspots there, and also allows me to look at the hotspots in my stored procedures. And when I find these hotspots using this tool, I can migrate them over. Now, the first thing I want to look at are the tables. So now looking at the table usage report, this report shows two dimensions. First, the vertical axis is the potential gain in performance that you can get from migration. So the higher up you are, the higher the potential gain from migration. The horizontal axis shows the effort to migrate the table over. The further to the right, the less effort you are. So you really want to look at the top right quadrant here, which are the prime candidates for migration to in-memory. In particular, I have my one table here, the ticket reservation detail. This is really the prime candidate for migration. So now I want to migrate this table to in-memory. Now, I could write a script to drop the original table and recreate it as a memory-optimized table. But for demo purposes, I built this into my simulation app. So I can now go ahead and migrate the table. So I run now the script in the background, which drops the old disk-based table and recreates a new memory-optimized table. And now I can run the same simulator, the same workload, but against this new memory-optimized table. And you can see right off the bat, I get 6x performance gain. So I'm sure Andy is going to be very happy now, because this is definitely going to solve the performance problem.
Well, Andy's not going to be just happy; he's going to be ecstatic, because you also didn't cost him any money, because he didn't go buy any new hardware, he didn't have to shift anything, didn't have to rewrite the app. And 6x, pretty impressive. Pretty impressive.
That's right. That's right. I did not need to rewrite the application, and this is running on the exact same server.
So where did the 6x come from? Why do we get?
First off, you see, we don't have any latching. So we get rid of pages, so we don't need page latches. This means we can utilize the CPU fully. Second, in-memory OLTP allows more efficient data access, so we can utilize the CPU more efficiently. So we get performance gain from these two factors. No pages, so no latching, and more efficient data access.
Okay, that's awesome. And so you showed us in the analysis tool also you could look at stored procs. Are you saying there's more performance to be gained?
Very observant, Tracy, very observant. Indeed, there is more. And if I look at the stored procedures, I can even potentially get more by migrating my stored procedures as well. So let me go back to SQL Server Management Studio. And indeed, as Tracy pointed out, we have here also stored procedures, an analysis of the performance of my stored procedures. So let me take a look at that. So this report shows my top stored procedures that could gain from migration to in-memory. You have things like my insert reservation details, read reservations. These are prime candidates for migration. So again, migration is similar than for tables. You drop the original stored procedures, recreate the new, what we call natively compiled stored procedures. So also in my simulator app, I built in a script for dropping the old stored procedures and creating the new ones. So let me go ahead and do this migration. And let me start the workload again. And as we can see, this goes up to 26, 27x.
Very impressive,
Oh.
very impressive. Again, to highlight this, right? There was no change to the hardware. There was no change to the app other than converting to use the new in-memory functionality. So that's quite impressive.
That's right.
Awesome. And now, so why the 27x? I asked you why the 6x. Now, why the additional?
So we get this performance by taking the T-SQL stored procedures and by compiling them to machine code. So we take T-SQL, run it through the query optimizer, take the query plan, and compile it to a DLL, load it in memory, and then we execute the DLL for very, very efficient execution of the business logic.
Okay, great. Thank you.
Yeah. So I got now as DBA, I got three really great things out of SQL 2014. First, I got the tools to analyze my workload and find the hotspots in my application and solve my performance problems. Second, I did not need to rewrite my application, and I could run it on the exact same hardware. And third, I have now a lot of headroom. 26x gives me a lot of headroom for any future growth, for further scaling, and for additional users. We can serve a lot more customers with the same application, the same hardware for years to come.
Great. Thank you, Jos. The thing I like to highlight before I go to that, actually, I want to go back to, if you remember, Dr. Snow had the 3 phases that he went through. He collected a bunch of data, thought he had an idea that it was a water pump, needed to get external sources to actually validate it was a water pump, and then ultimately made a change and an action. It actually comes back, if you looked at the scenario we went through, and the first data that Andy came up and showed us, it was very quick and easy to see we had weather delays in certain parts of the country. It would also have been very easy to surmise that people were just upset by those delays. But we didn't have the app data rolled in yet. We didn't have the weather data rolled in. Once we rolled all of that stuff in, we actually came to a better conclusion that it was widespread in certain areas. And in fact, our most premium customers that we cared about the most were the most upset with it, which gives us great insight to go back and look at how we would adjust our app. And then we also found out we had a throughput problem with that app. That would have been pretty hard to know otherwise, because we would have just blamed it on the weather in that regard. And so those set of things enabled us to come to a point. And as Jos shows, we would have used this technology that would have not only not gotten a 2x or a 3x, but a significant growth in throughput that we wouldn't have had that problem again. Actually, we probably wouldn't have had it for quite a while. And the thing that I would go back to Dr. Snow was he changed the way people thought about how bacteria was transferred and how cities dealt with water. Well, in this case, I would say that same thing comes into how would you deal with your app. If you knew that your app could get 6x the throughput that it does today, would you do things differently? And I think you would. If you knew it could get 20x over what it does today, would you do things differently? And I think you would, because we've all created our apps and you know where your boundaries are. And so it gives different opportunities for growth on how you want to tackle your development. So that's one piece of SQL 14. And again, you see, I'll be kind of passionate about this because my team is responsible for SQL 14. But the in-memory work is work we've been working on for several years. And it'll be coming out in SQL Server 2014. We've also, but it's not the only thing we did. We also looked at a lot of customer feedback and a lot of customer data over the last year and a half into other parts of our offering and enhanced those. In particularly, Always On was a new functionality, our HA functionality that came out in 2012. We've enhanced that based upon purely customer feedback that we've heard of where they thought we needed enhancements. And so there's a whole set of things tackled there. The column store has been another place that we've improved the technology as well. And then lastly is hybrid. And you probably heard about this in the keynote some, where we said, hey, how do we connect this on-premise world to the cloud world? And we have several specific investments in SQL 14 that do that. Backup is the obvious one that backs up to the cloud. We have secondaries that can be up to the cloud as well. And what we don't discuss here as much is we have IIS in the cloud as well, and you can tie the two together. So there's a lot of interesting work to go through and do that. Yoast has some sessions later this week. I think one today, one tomorrow, that I'd highly encourage people to go and check out, and you'll find out all the details in that regard. And a lot of times when I show this, people will come to me and say, well, man, but you guys just did SQL Server 2012, and you're doing this in such a short time frame afterwards. And the reality is we've been working on the OLTP in-memory part for the better part of 3 or 4 years. And it's to the point where we wanted to get it in the hands of customers so they can get these big improvements and tackle that through in that regard. And so it's great in that is SQL. I mean, that's all I can say at the end of the day. It is SQL. And so it's some tweaks to your application to get that advantage and throughput as you go through. So last thing on that, the preview of that is out today. So you can download that, which is very exciting for us. So again, highlight the 3 phases that we went through. The big part that I want to highlight in this though, is to remind people is, at the end of the day, we tried to make it easier for you to go through the phases, more powerful for what you get out of it, and then complete. And so if you walk through the examples of what we did with our app of going through that, many things that both Andy and Yoast walked through were not possible a year ago, were not possible 2 years ago, were not possible a couple weeks ago. I mean, they are doing things that is really moving it along. And if you go through the tipping point that we talk about data, we still have a ways to go. This is a big area we are investing in because the world is just getting more complex in regards to data. But as you have more, you have to quickly find it, you have to quickly process it, and then you have to quickly take action on it and use it and go from there. So it's an exciting time. One thing that I don't think we all think about as much is, because we're probably all in it, is I think this will be a time period that we will all look back on in our careers and go, man, this was a major turning point in the industry as it relates to data and the different technologies that we create and change in order to tackle it. So on that, with a final note, was just a reminder of the technologies that we talked about. Again, there's the data warehousing, PDW. Big data was our HD Insight service, Excel, and that. And if you look on the bottom, it gives you the actions of these things. So I actually tend to think of data warehousing and big data as a group together, all around big data. And so I'd highly encourage people to try out the HD Insight preview that's out there. Excel in Office 2013, you'll start to see the things that we have there in the preview for that. And then lastly, SQL 14 is available as of today to download our first preview for that. And then we will be having another preview later this year. It's an exciting time for that, so I highly encourage people to check it out, try it out, and give us feedback on it. So thank you, everybody, for your time. Thank you.
EdgeNet provides software and services for the retail industry. Our solutions are really focused on selling product, so it helps retailers sell more product to their customers and helps customers find products easier. When a customer is shopping online, they have to have a great experience. They're just going to go to another website to buy the product they're looking for. So that experience needs to be very concise and give them the information they want in a quick manner. Looking at the progression of in-memory systems from Microsoft with Power View to 1 billion rows in Power Pivot, we knew that in-memory OLTP would be a game changer for us. One of the things that we had a problem with was being able to have real-time product updates as well as having that system online for consumers to use. With in-memory OLTP, you don't use the disk. everything is cached in memory, so that speed constraint of disk is gone. You can support a lot higher load on a smaller machine, and it's very efficient at memory that it uses. You don't need large servers for it. The traditional system was updated once a day, and the process took a few hours. The new system can be done 7 times faster in about 20 minutes, and the system isn't down while it's being updated. That information is streamed directly into that database, and it's always real time. One of the great things about SQL Server in-memory OLTP is it uses the same tool set that developers and DBAs are used to. To them, it looks basically like standard SQL Server. Using this technology, we can provide real-time product updates and real-time information that other people can't provide. In retail, speed is everything. With our systems and in-memory OLTP, our customers can accelerate their business over their competitors.